All right, ladies and gentlemen, welcome to lesson 1.6. We're doing this fireside chat version tonight. You can probably see the fire behind me. It's a little chilly today, so I enjoyed a nice fire in the fireplace. In any event, you can see your I can statement at the top. I can add and subtract like mixed numbers. We're going to do some practice with that today, so please write down an I can statement, and again, any additional notes that you feel will be helpful when you have to do this in class. Now we're going to run through some examples. So, adding like mixed numbers. We're going to start with that. So let's look at a number story. Samantha swam 1 2/3 lengths of the swimming pool this morning and 1 2/3 lengths of the swimming pool this afternoon. How many lengths did she swim today? Well, I have to add those together to figure that out. So one strategy I can do is I can draw a picture to help me visualize this better. So I can list 1 2/3 twice, and I can draw the fraction bars that show me what that looks like. After I've done that, I can start counting how many holes that I have, or hole number ones. Okay, so I've got one hole here and one hole here. Now you'll notice that there are 3/3 to make one hole. So I'm going to take 3/3 out of the other shaded portion. That's going to give me an additional one hole. Now what do I have left behind? Well, I have 1/3 left that's not accounted for. So now I just need to add that string of numbers up. So I get 1 plus 1 plus 1 plus 1/3. And when I add that all together, I get 3 1/3. So that means that Samantha swam 3 1/3 lengths today. All right, let's look at another way we could do this. We could add the whole number parts and fraction parts separately and then regroup. That'll make more sense when we do this. So here we can do it horizontally. So let's take a look at this problem right here. We've got 1 2/3 plus 1 2/3. I'm going to separate the whole numbers from the fractions here. So we've got 1 plus 1 plus 2/3 plus 2/3, which equals 2 4/3 when I add that together. Now, to go one step further, I'm going to take the 2 and I'm going to make 4/3 into 3/3 plus 1/3. And I'm going to do this because 3/3 equals one whole. So now I'm going to take the 2 plus 1, which is 3, plus the 1/3 is going to give me 3 1/3. I can also do this vertically. Okay, you can add them up. Fractions get added first. You'll still work from right to left, so we're going to add those fractions first. That's going to give me 4/3, and then the whole numbers are going to give me 2. And then I'm just going to convert that over like I did in the other one. Okay, I'm going to take 3/3 out, make that an additional 1, and now I've got 3 1/3. You can see either way works. You just have to go with what you're comfortable with, and that includes the fraction bars as well. Okay, so let's talk about converting and adding. We can rewrite the mixed numbers as fractions and add them. And what I mean that is we can turn these mixed numbers into fractions that are greater than 1. So we've got 1 2/3. So I'm going to take the 1 and make it into 3/3, and I'm going to add it to 2/3, which is going to give me 5/3. And I'm going to do that twice because they're both the same in this case. And that's going to give me a total of 10/3. As a reminder, whenever we see a fraction like this, you can see this line here actually stands for division. It means 10 divided by 3. So I'm just going to quickly draw that as a division problem. And I'm going to ask myself, and this will be a little review of long division for those of you who maybe are a little rusty on it. So we're going to do 10 divided by 3. Well, what's the most 3's I can get out of 10? Well, that's 3. And I multiply 3 times 3, that gives me 9. I'm going to subtract 9 from 10, that's going to give me 1 left over. And I'm going to take my remainder. Okay, try a little picture here. I'm going to take my remainder. It's going to become my numerator. And my divisor is going to become my denominator. So that's going to give me 1/3 or 1/3. That's 3 1/3 again. All right. Now let's talk about subtracting like mixed numbers. And we're going to look at a couple different problems today. Let's look at this first one. I have 3 5/6 yards of string. I cut off 2 1/6 from my sister. How much string do I have left? Well, let's stack these up. As I told you before, we're going to look at the fractions first. When we're talking about subtraction, we have to check, is this fraction large enough to subtract the fraction below it? In this case, it is. So I don't have to do any borrowing to solve this. So I'm going to subtract my fraction portion first. 5/6 minus 1/6 is 4/6, and then 3 minus 2 is 1. Okay, so I have 1 4/6 yards of string left. Now I can also write that as 1 and 2/3 because 4 6 can be reduced because they share a common factor of 2. All right, now let's look at a different type of fraction problem. I rode 7 1/5 miles on my bike. My friend rode 2 4/5 miles. How many more miles did I ride than my friend? Well, I can already see it's a subtraction problem by that keyword. How many more, or keywords? So, excuse me. So let's look at 7 1/5 minus 2 4/5. I can see when I look at this, there's no way that 1 can take away 4 without me doing some borrowing first. So, one method we can use to do that is to do something called ungrouping. Here's one way to do it. We're going to take 7 1/5 and we're going to take 1 whole out of it, which is going to leave me with 6 wholes, or the whole number 6. Now I'm going to turn the one that I took into a fraction, okay, which would be 5/5. Now how did I know this was 5/5? Well, I just looked at my denominator over here, that's 5. I know my numerator and denominator are the same, they equal the whole number 1. So I've got to stay with the denominator I have, so that's going to be 6 plus 5/5 plus 1/5 for a total of 6 6/5. Now when I put 2 4/5 underneath it, I can subtract. So 6/5 take away 4/5 is 2/5, and 6 take away 2 is 4, so my answer is going to be 4 2/5. I could also just simply stack these. Some of you who fractions come a little easier for, this might be a better method for you to use. Again, you guys got to pick what you like. So I've got 7 1/5 again. I know that 1/5, you can see it right here, 1/5 cannot take away 4/5. It's not big enough. So I'm just going to borrow here. And I'm just going to do that part that I did over there in a slightly different way. I'm just going to go ahead and borrow 1. I'm going to turn that into 5/5, and I'm going to add that together. 6 6/5, subtract, and again I'll get 4 2/5 as my answer. Okay. Another way you can do it is add on, and this is a method that I actually really like. It's really helpful, especially if you find sometimes looking at fractions a little tricky for you, and this is a good way to handle this. So the first thing I want to do is I want to ask myself if I'm going to basically be counting up here, okay? So I'm going to ask myself, how do I make 2 4/5 into 3? Well, I add 1/5 to it, okay? So it's 1/5 away from 3. And now I'm going to ask myself, I'm going to go between whole numbers. So I'm going to ask myself, how far is it from 3 to the whole number in my other fraction here, which is 7? So from 3 to 7, that's the whole number 4. So I'm going to add that to the 1/5 that I had before. And now I've just got to figure out how far it is from 7 to 7 1/5. That is also 1/5. So now I've got an addition problem. 1/5 plus 4 plus 1/5. Well, I'm going to add my fractions together. That's going to give me that 2/5, and I've got the whole number 4, so that's going to give me 4 2/5. And you can just simply count up as you work across. Good way to kind of work your way through that, especially sometimes if you struggle a little with the borrowing portion of subtraction. So here's some practice problems for you today. In numbers 1 and 2, you need to add up, subtract. Well, they're not really numbered, but you can see these are the 2 problems. Be sure to show me your work. I noticed in a lot of the seat work that I'm seeing, I'm not seeing your work. That's going to be a requirement, so just make sure you're doing that, and then you need to solve and show your work for the story problem down here below, which you can read, okay? And if you have any questions about this, we'll discuss them in class. Have a great night.